So here we have a motor which uses a cable to pull a trolley up an inclined plane at constant velocity. So this is the keyword here. Constant velocity would mean acceleration is equal to zero, which means the net force, according to the Newton's second law, will also be zero as F is equal to ma. So whichever forces are acting on this trolley, all of them will add up to get the zero resultant force. Now we need to figure out of the three statements given, which of them are correct regarding the energy changes of the trolley. All right, so before we go ahead and solve the question, the step one is always remember, please draw the free body diagram of the trolley. How many forces will act on this trolley? So the first force is the obvious one, the weight of the object. So let's draw that. Let's call this as WG, which is the weight. And then we have the normal reaction perpendicular to the contact surface. Then there will be tension in the string, which will be the force which is provided by the engine of the motor. Apart from this, there is frictional force, which will be acting backward. So it will act down the inclined plane F. So overall, there are a total of four forces acting on this trolley. In statement number one, we need to figure out, is the work done by the engine greater than the work done by friction? So how do we do that? We will use the work energy principle. Now, since we have non-conservative forces here, friction is the non-conservative force. This pulling force provided by the engine is also non-conservative force. Now, remember the concept, whenever non-conservative forces are acting on the system, we apply the work energy principle. So let's write down the total work done by all the forces acting on the trolley should be equal to the change in kinetic energy. Now, since velocity was constant, so change in kinetic energy we will write as zero. Now we have four forces acting here. So let's write down one by one. We'll write work done by normal reaction plus work done by the engine plus work done by the frictional force small f plus work done by the weight of the object. Let's call that as mg. Mg is the weight. All of this will add up to zero. Now, work done by normal reaction is always zero, as we know, because normal reaction is always perpendicular to the displacement. Work done is Fs cos theta. So let's write it down. This is just for revision. Work done is Fs cos theta. But for the normal reaction, n is always perpendicular to the contact surface. So theta will be 90, cos 90 becomes 0. So work done by the normal reaction will be 0. Plus work done by the engine force Fe plus work done by friction. Then we have the work done by mg equal to 0. Now mg, the weight of an object, is a conservative force, and we know the formula. Work done by any conservative force is equal to negative of the change in potential energy. So here we will write work done by the gravitational force will be equal to negative of change in the gravitational potential energy. Let's write this further. So overall we will get work done by the engine force plus work done by the friction minus delta GPE will be equal to 0. Now, this negative delta GPE can be taken to the right hand side of the equality sign. So, if we do that, let's see what do we get. Work done by the engine force plus work done by friction will come out as delta GPE. So, change in the gravitational potential energy. So, in this question, the trolley is actually going up the inclined plane, which means the final potential energy will be greater than the initial potential energy. So, which means the change will be positive. Change, remember, is final minus initial. So, in this case, the delta GPE will be a positive quantity, which means now I can write work done by the engine force plus work done by the frictional force is a positive number. Now, it is important for us to remember the sign of the different work done. So, if I go back to the question, the engine force is being acted up the incline. The trolley is also moving up the incline. So, the work done by the engine force will be positive. So, work done by the engine force, let me write this, will be positive. On the other hand, work done by friction will be negative. And why is it negative? Because the trolley is going up the incline, but frictional force is acting down the inclined plane. So let's write down work done by friction will be negative. So let us say work done by the engine force. Let's consider that as plus x, since it is positive and x is the magnitude. Work done by friction, on the other hand, we will consider as negative y. Minus is the sign and y is the magnitude of the work done by friction. So x minus y needs to be a positive quantity, which means we can write x is greater than y. And what was x? X was the magnitude of the work done by the engine force that will be greater than magnitude of work done by the friction. And if you go back to the statement one, this is what it exactly says. Work done by the engine has a greater magnitude than the work done by friction, which we have proved, which means statement number one is definitely correct. All right, statement number two. The total of kinetic and potential energy of the trolley increases. So let's analyze this. Some students might mark this statement as incorrect as they are under the impression that the total of kinetic and potential is mechanical energy, of course, but they are always under the impression that mechanical energy is always conserved, which is not true. You cannot conserve mechanical energy if there are non conservative forces acting on the system. So here, we have friction, which is a non-conservative force. Normal reaction is another non-conservative force, although the work done by normal reaction is zero. Then we have the engine force, which is the pulling tension force. That is also non-conservative force. So in presence of these non-conservative force, mechanical energy is never conserved. So statement 2 cannot be right. So in any case, let us write down the total of kinetic and potential, which is also called mechanical energy, kinetic plus potential energy. Now, in the question, it was mentioned that the velocity of the trolley is constant, which means kinetic energy, the half mv square, will be constant. On the other hand, potential energy, the formula for gravitational potential energy is mgh. Now, in the question, the trolley was going up the incline, which means its gravitational potential energy is going to increase. So potential energy, we will write this is going to increase definitely. On the other hand, kinetic energy is a constant. Now, what will be the sum total? Kinetic plus potential. Total mechanical energy will therefore increase because the potential energy was increasing, which means even statement number two is correct. Statement number three is the gain in the gravitational potential energy of the trolley has the same magnitude as the work done by the engine. This we have partially solved earlier in the first statement. Work done by the engine force plus work done by friction force is equal to delta GPE. So let's write it one more time. So here we go. Work done by the engine force plus work done by friction is equal to delta GPE. In statement 3, we are supposed to find this gain in gravitational potential energy, which is the right hand side. According to statement 3, that should be equal to the work done by the engine, which is clearly wrong because delta GPE is equal to work done by the engine plus work done by the friction. So we can write the delta GPE is not equal to work done by the engine force. They would have been equal if the work done by friction would have been zero. In that case, the equation would have satisfied. So in the current case, statement number 3 will be incorrect. So let's look at the options. Option A will be the right answer for this question.